everybody, this is Gigi from Kauai Community College. This is a video on symmetry. Let's get started. So suppose you are looking at the given point A, and in this case the point A that we are referencing is one with coordinates 2, 3. Okay. Now if we look across to point B, the coordinates for point B is 2, -3. B is directly across from the x-axis to A. We say that the points A and B are symmetrical with respect to the x-axis. So when you have a graph, if all points xy on the graph has a respective point x -y on the graph as well, then the graph has symmetry with respect to the x-axis. Now, point D has the coordinates of -2, 3, and it is directly across from the y-axis to point A. So we say A and D are symmetrical with respect to the y-axis. So notice the x value is the opposite of the original x value. So we would say that for all points xy on a graph, if the point -xy is also on the graph, then we have symmetry with respect to the y-axis. Now let's look across to C in respect to point A. C is directly across the origin to A, and the coordinates of C is -2, -3, whereas A is 2, 3. So we say for all points xy on the graph, if the point -x, -y is also on the graph, then we have symmetry with respect to the origin. Now think about a function. Which of these types of symmetry could a function have? Pause and ponder. Now let's look at symmetry in a graph. This is symmetry with respect to the x-axis, because for any given point xy, there is a corresponding point x -y. So every single point xy, there is a respective point x -y on the graph. So this has symmetry with respect to the x-axis. And because it has 2 points on a vertical line, it will fail the vertical line test. So a graph with symmetry with respect to the x-axis is not going to be a function. So here is a picture of what it means to have symmetry with respect to the y-axis. For any point xy on the graph, there is a point -xy on the graph. So for any given point xy, there is one across from the y-axis. Well, this graph just happened to pass the vertical line test, and it's a function. The next example you see here is an illustration of symmetry with respect to the origin. For any point xy on the graph, there is another point across from there, and that value is the opposite of x and the opposite of y. So it has symmetry to the origin. This also passes the vertical line test, so this graph is a function. Now, I just said before that if a graph has symmetry with respect to the x-axis, then it wouldn't be a function because it would definitely fail the vertical line test. What about symmetry with respect to the y-axis and the origin? Does that imply a graph is going to be a function? Ponder this one. True or false? Symmetry with respect to the y-axis or the origin implies that the graph is a function. Well, that is false. And here's your counterexample. Symmetry with respect to the y-axis. Symmetry with respect to the y-axis. Right? Symmetry with respect to the origin. But it definitely fails the vertical line test. So it is not a function. So really be careful of what we're saying, right? We know that if it's a function, it is not going to have symmetry with respect to the x-axis. And if it has symmetry with respect to the x-axis, then it is not going to be a function. However, this particular statement is false. How do you test for symmetry when all you are given is an equation? Well, think about the points, right? So for x-axis, for the symmetry with respect to the x-axis, you're checking, is the point x negative y on the graph? So what are we going to do? We're going to go and substitute x negative y into the equation that is given to you. If it yields an equivalent equation, meaning if it becomes the same thing, then we would say the point x negative y is also on the graph because it will make the equation true. Now, let's just take a look at the substitution. Negative y squared is equal to 7 minus 2 times x. Negative y squared, well, negative numbers square up, it's going to be a positive. So it becomes the exact same equation as the original. So we say it has symmetry with respect to the x-axis because the point xy is on it and the point x negative y is on it. Now let's check for symmetry with respect to the y-axis. We are saying, well, if xy is on that equation there, and it does have symmetry with respect to the y-axis, then negative xy should also work. Let's see. If you substitute in negative x, y, you will get y squared is equal to 7 plus 2x, because negative times a negative is a positive. That is definitely not the same equation that you had before. So the point negative xy is not on the graph. So it does not have symmetry with respect to the y-axis. Well, what about the origin? We want to say, well, is negative x negative y on the graph? Let's go and do your substitution. Negative y squared, negative number squared is a positive number. Negative times a negative is a positive. Well, that is not the same as the original either. So it does not have symmetry with respect to the origin. A concept that is related to symmetry is even and odd functions, which we'll do in the next video. So look for that one next.